Hello there, this is Mr. B, and today I want to talk to you about real-life equations. Yes, real-life equations. That's what it says up here. Basically, what we're doing is we're looking at an equation, and we're not solving anything. We're not finding the answer. We're simply trying to relate two variables. So in each of these equations, you'll see that there are two variables. There's an x and there's a y, and they mean something. So in all real-life type problems, equations will represent the real life situation using variables that mean something. So you have to know what the variables mean. And of course, here we see x and we see y, and x is the number of chairs and y is the total number of legs on all the chairs. Okay, we're just going to assume that all the chairs have 4 legs on them. That's a pretty safe assumption. I wouldn't like chairs with only 3, or 2. Like, that would be really hard. But anyway, we've got these 4 equations, and 2 of them correctly represent the situation that relate the number of chairs there are and the total number of legs there are. Can you pick which 2 correctly relate these 2 variables and the other 2 do not? So go ahead and pause this video. I'll ask you to do that a lot during this video, so you can pause, you can think through it and see if you can figure out the answer, and then we'll come back and we'll answer that for you. So go ahead and pause and pick the 2 correct equations. Okay, let's take a look at these. I'm going to focus on a couple of these 2 right here. And let's zoom in here. Okay, if we just focus in on these 2, one of these is correct and one of these is not. One thing we want to do is know how to read an equation from left to right. It's like a sentence you're saying. When we read this, normally we'll say, okay, x equals 4 times y. So we do know that 4y means 4 times y. It would not be correct to say I have 4 chair legs. It's not 4 chair legs. And over here, when we see y equals 4 times x, it would not be correct to read this as the total number of legs is the same as 4 chairs. 4 chairs is not what this means. This means 4 times the number of chairs. And this means 4 times the total number of legs on all the chairs. So that may help kind of simplify our thinking when we're trying to figure out which of these correctly relates chairs and the legs on the chairs. Same thing when we look at the other 2 over here. We see some division problems. So we're saying that the total number of chairs, here we are. Over here we see on letter C, the total number of chairs, I'm just reading this. Instead of saying x, I'm reading what the meaning is. So the total number of chairs is the same as you take all the legs of the chairs and divide them by 4. Or over here, you take the total number of legs is the same as the total number of chairs divided by 4. Well, one of these makes sense and one of these does not. So before we answer this, I want to go on to some questions here. So let's take a look at this real quickly. Now, take the context out of it. There's a y, there's an x. I see 4 times x. Which is greater, the x or the y? Think about this for a second. Pause if you need to, and then come right back. Okay. X and Y, here are 2 thoughts about this. Here we've got these 2 people here, they're throwing their ideas out. This is Billy Bob. Billy Bob says X is greater, obviously, because you're multiplying it by 4, and that'll make it greater than Y. This is Sally Bob. Sally Bob says, well, it depends on what X and Y are. Okay, so which one of these do you think is correct, right? Well, let's just make some examples. Let's do an experiment here. Let's pick a value for x. Let's just make x equal 2. Okay, so x is 2. This is a good experiment to do whenever you're not sure about something. Just pick some numbers and let's see if this works. Okay, if x is 2, this means 4 times 2. Well, then what would y be if x is 2? Yes, 4 times 2 is 8, so y is going to be equal to 8. 4 times 2 is 8, y equals 8. So obviously we can see here that y is greater than x. Y is always going to be greater than x, is it? Sally Bob says it depends on what x and y are. Is it possible that they could be the exact same number? Can you think of some number to put in here for x that y and x would be the same number? What about the number 0? If x was 0, this would be 4 times 0. y, of course, is going to be 0. So in this case, they're the same number. Y and x are equal to each other. Can you think of a possible number for x where y would be actually less than x? Well, if you thought of maybe a negative number, if you know multiplying by negative numbers, so 4 times, this is the parentheses right there, sorry, 4 times negative 2 is going to equal negative 8. And on a number line, if you think about negative 8 and negative 2, negative 8 is further to the left, which means it's going to be less. So Sally Bob's right. Sometimes y can be greater than with positive numbers. Sometimes they could be the same with 0, and sometimes y would be less with negative numbers. So that means for our purposes today, we are only going to think of positive numbers, because when we start talking about a situation, negative numbers really don't make much sense. So let's take a look at this right here. I want you to think of an equation with these two variables. We're going to make an equation that relates the number of eggs, the total number of eggs, to the total number of egg boxes that you buy at the store. Now, these egg boxes only have 6 eggs in each box. So go ahead and think about an equation. Pause right here. Write an equation down. See if you can come up with it, and then unpause. Okay, we're back. There's a couple of possibilities we have right here. We've got Billy Bob saying B equals 6 times E, and we have Sally Bob saying E equals 6 times B. Which one is correct, do you think? Billy Bob, I think, he's thinking about, I think, ratios. I think Billy Bob is reading this and saying 1 box is the same as 6 eggs. That kind of sounds like it might be right. I mean, 1 box is the same as 6 eggs. Sally Bob is saying the number of eggs you have is the same as 6 times the number of boxes that you buy. So which do you agree with here? Well, Billy Bob, I'm sorry, but you're making an error in thinking that. Billy Bob's kind of thinking about ratios. So this is, I think, kind of how he is thinking. You know, he's thinking, okay, for every 1 box, there are 6 eggs. That's ratio thinking, and that's a good way to think, and that is true. For every 1 box, there are 6 eggs. But this is not a ratio. This is an equation. There's operations going on here. This does not mean 1 box is the same as 6 eggs. 6E is not 6 eggs. 6E means 6 times the total number of eggs there are. So I'm not sure if that makes sense. We can also take a look at a table. I mean, this may help kind of polish our thoughts about this and guide us in the right direction. Think about the number of boxes and the number of eggs. If I bought 1 box, how many eggs? Okay, obviously 6 eggs, right? What if I bought 5 boxes? How many eggs is that? You know, I'm sure you got 30 right here. So what math are we doing? What did you do to B to get the number of E right here? You're multiplying the number of boxes times 6 to get this. So Sally Bob, check mark over here, check plus, put a plus there. Yes, good job, Sally Bob. So that is correct. 6 times the number of boxes equals E. This is not correct. This is incorrect there. So let's take a look at something else. Let's take a look at the cost of eggs. Okay, so here are 2 possibilities about the cost. Here, E is the cost of an egg, 1 single egg, and then B is going to be the cost of a box, 1 box of eggs. So which of these would be correct this time? Okay, let's examine here. Billy Bob is saying a box B is the same as 6 times the number of eggs there are. Okay, that's good. How about this means, Sally Bob is saying the cost of a single egg is 6 times the cost of a box of eggs. Well, I think Billy Bob has got it this time. Check plus, Billy Bob. We can experiment with this too. All right, so let's say the cost of an egg was $1. Okay, 1 egg is $1. That means 1 times 6, we're going to put 6 times 1. 6 times 1 is 6. So if 1 egg is $1, then a whole box would be $6. That makes sense right here. But over here, 1 egg, or I'm sorry, the cost of an egg is $1. If I put a 1 here, and then the cost of if the cost of an egg is $1, and there's 6 of them in a box, I know that's got to be 6, right? So this would not make sense. 6 times 6 is not going to be 1. So that does not work out right there. Okay, let's move on to some exercises. Okay, here we have an exercise real quickly. I have 5 or 6 situations. I just want you to match them up to the correct equation. Okay, you see some of these equations include x and y's as variables. Those are the cost of apples and bananas. And some of the equations include a's and b's, which are the number of apples and bananas. So keep in mind, you have to use the correct variables for this right here. Let's take a look at the first one right here. Not the whole thing, I just want one. Here we go. All right, bananas cost twice as much as apples. So I know right away I'm dealing with x and y's right here. Go ahead and pause right here. You figure out which one is the correct equation. Okay, yeah, we're looking at x and y's. Bananas cost twice as much as apples. I know if I had one apple, if apples were $1, see, I'm making an experiment here. Let's do an experiment. If apples cost $1, what would bananas cost? $2. What did I do to the number of apples or the cost of apples to get that answer? So is it this one? Nope, sorry. It's not that one because this is A and B. This is the number of apples. Can't be that. Is it? It's got to be an X and a Y. This one, that could be it. Or there's X and Y. These two are kind of like the opposites here. So this is saying 2 times the cost of apples, double the cost of apples equals the cost of bananas. This one says I double or I multiply the cost of bananas by 2 to get the cost of an apple. So the bananas cost twice as much as the apples. So I think, let me erase this stuff. The cost of bananas is double or twice the cost of apples. So that's the one right there. So we're going to put this next door. Right there. Next one. The apples I bought cost $5. Okay, pause, find the equation, come back. All right, so how do you find the cost of apples? Well, you have to figure out how many apples you bought and then multiply it by the cost of an apple. And it's $5. So if you picked A times X equals 5, I think that is correct right there. So let's go ahead and shrink this down and put this in place. Good job. Next one. Okay, altogether, I bought 5 apples and bananas. They're buying some, so go ahead and hit pause, come back. All right, since you're buying a bunch, we're not talking about cost, we're talking about the number of apples, so A and B. Altogether, we're adding these things together, so it looks like over here, B plus A equals 5. So that's a good bet right there. The number of apples, or the number of bananas plus the number of apples equals 5. That is the same as that there. Let's take a look at here. What do we have? Apples cost half as much as bananas. All right, work this one out. Do a little experiment. Make up something for apples and bananas, a cost for those, so that would make sense. And which of these expressions or which of these equations represent that? Okay, pause and come back. Okay, it looks like, let me see, we're looking for X and Y. There's 2 times something. That still might be it. I mean, this could be a possibility here, X and Y. This right here relates X and Y, so you divide by 2. Also this one, and it may be more than one too. So let's read each one of these. This up here says the cost of an apple, or cost of apples, is the same as 2 times the cost of bananas. 2 times. That means apples cost more than bananas, and that does not represent that. So in this case, apples are not more than bananas. So it's definitely not that one. So here, let's see this one. It says the cost of bananas is the same as you take the cost of apples and divide it by 2. So if I divided the cost of apples by 2, that would be the cost of bananas. If the apples were $4, right, then this says I would divide it by 2, and the bananas would be $2. So in that case, apples are more expensive than bananas. And that's not this one here. Let's just double check this one right here. The cost of apples, X, is the same as you take the cost of bananas and divide it by 2, or take half of it. That does match up with what we're talking about here. Apples are half as much as bananas. We would divide the cost of bananas by 2, or multiply by 1/2. Also, you might have noticed, this is the same thing. Bananas cost twice as much as apples. Apples cost half as much as bananas. So these two are the same right here, those and this one. So this equation and this equation both match both of these situations, 1 and 4. All right. And I guess we could have put this one down here too. So, I mean, they're the same. They're equal. They're all equal to each other. All right, how about our last one right here? Pause and come back. I bought twice as many bananas as apples, so we're going to be looking for A and B. Let's look at this one. The number of bananas is the same as twice the number of apples. The number of bananas is the same as twice the number of apples. So if I bought, let's just make an experiment here. If I bought 2 apples, that means I bought 4 bananas. Okay, is that this? I bought twice as many bananas as apples. Here, we have more bananas. Over here, we have twice as many bananas. We have more bananas. That works right here. I bought twice as many bananas as I did apples. So I would take apples and multiply it by 2. Okay, that works. Is there anything else? What about this? The number of bananas divided by 2. If I divided the number of bananas by 2, I would get the number of apples. Well, using these same numbers, if I bought 4 bananas, then if I divided it by 2, I would get 2 apples. Okay, that's the same numbers. These two work in the same way for this one situation. So both of those will work. Just like we saw with this one, number 1 and number 4 down here. Number 5 works for both of these equations. Okay, I got a trick one here for you. Bananas cost $2. Which one do you think that is? Okay, I know you all want to say this one right here, right? Something's wrong with this one. X, it's not this one. B is not cost. So this is talking about the cost of bananas, and B is the number of bananas. So we need the cost of bananas, Y, to equal 2. So that one does not have an equation up here. It's a trick question. I just kind of want you to think about that one. It's good to catch up. Actually, in this exercise, there were some blank ones down here where we would write our own. So definitely we would want to write Y equals 2 down here. Okay, that's it for those exercises. Real quickly, if we came back and saw this, the number of chairs, the total number of legs on the chairs, which equations would work out? B would be correct right here. The number of legs, the total number of legs, is the same as 4 times the number of chairs there are. And which one of these two? It's going to be C. Yes, so we can read this as the total number of chairs would be the same as if we took the total number of legs and divided it by 4. That would tell us how many chairs there are. So congratulations on doing that and finishing this video. Thank you very much, and I'll see you next time.